Hello students. So today I'm going to deal with the numerical, which is for the part of electrostatics, and the numerical is that find out the electric field due to an uniformly charged wire of length twice L and charge density lambda, which is linear charge density, without using Gauss's law or Gauss theorem. So you cannot use the Gauss's theorem. So without using Gauss's theorem, you need to find out the electric field or electrostatic field. Let's do that. So I have considered here one uniformly charged wire of length twice L, and O is the midpoint. I am named here AB is that particular wire, and this is its equilateral axis, and let us consider this a point P. And since the charges are uniformly distributed, so you consider a section DL at this point B, and so with respect to this section DL, we need to find out the electrostatic field at point P. So what is the total number of charges present within this section DL? So here lambda is a charge density. Charge density can be represented as dq by dl. Okay, fine. So now what is the total number of charge over here? So the total number of charge must be for this section dl. So the electrostatic field at the point P will be 1 by 4 pi epsilon naught. That means we have to consider the free space dq. And now what is the distance? So the distance need to find out. So distance bp. Okay, so what I need to do is that this is the center of this wire, and from the center to P, let the distance be smaller. Let the distance be smaller. And since it's a length of twice L, so obviously AO is a length L and OB is also length L. Okay, that means the length OB is nothing but small l. So now this BP would be root over r square plus L square. Okay, so this would be r square plus L square. Fine. This is the thing. Now since this is a vector quantity in this direction, since the positive charge, so this is the direction of P. So let us assume that this is the angle of theta. Okay, and this is an axis. If this is theta, then this is also theta. If it is so, then we can resolve it into two components. One is along this, which is dE cos of theta, another along this dE sin of theta. Right? Fine. Now 1 by 4 pi epsilon naught dq means lambda dl, so r square plus L square. This is the expression of d magnitude at point this P. So this is the at point P, this is the value magnitude d at this end of length dl. Okay, so the distance will be same. So the distance AP will be r square plus L square. Okay, so the electrostatic field with respect to this section dl over here would be same in this direction dE. If this is theta, this is also theta. This is also theta. Resolve this dE into two components. One is here, another is here. So you are basically getting two components along this axis and this. So basically for these two part, these two components will get cancelled out. So which two will remain? This cos of theta. That means there are numbers of small sections for which we can get this dE cos of theta. Okay, that means the total electrostatics field at point P is the integration of dE cos of theta. This is the concept. That is the thing. Right. So if it is so, dE means 1 by 4 pi epsilon naught right? Lambda dl r square plus l square into cos of theta, right? Now see, from this triangle OPB, this is a perpendicular, this is the base, and this is the hypotenuse. So perpendicular by base gives you tan of theta. Perpendicular is nothing but this is twice L, so this is L, and base is R. So from triangle O L by R, so from the triangle OPB, L by R gives you tan of theta, and L is equal to R tan of theta. Now differentiate this equation with respect to theta. So dl divided by d theta is equal to R d theta tan of theta. So if you differentiate tan of theta, you will get sec square theta. Therefore dl is equal to R sec square theta d theta. Okay, fine. So now use this equation. What is this equation? What is this equation? So what we find out already, there is 1 by 4 pi epsilon naught lambda dl r square plus l square into cos of theta. Okay, so 1 by 4 pi epsilon lambda 1 4 pi epsilon is a constant term. Put it out. dl, replace this value, r sec square theta d theta. R square is a constant term. Why? Because this is the distance from the center of the wire to the point, and L can be written as square. Square both this and replace this L square over here. So you'll get R square tan square theta and cos of theta. So basically we are getting here this R sec square theta d theta r square 1 plus tan square theta cos of theta. 1 plus tan square theta gives you sec square theta, lambda 4 by epsilon naught. So r sec square theta r square sec square theta cos of theta d theta. Get cancel, 1 and r cancel. So 4 by epsilon naught 1 by r cos of theta d theta. Theta is going to be shift. Theta becomes smaller, isn't it? If you consider the dl over here, theta will be more smaller. That means this end theta become decreasing, and for this end, if you consider the theta over here, initially with this axis, angle would be 10, and let us consider 10 degree. If you consider here, the angle will be 30 degrees. So simultaneously, when this theta decreasing, this theta get increased. So one limit is minus theta and another is plus theta. Lambda by 4 pi epsilon naught. We do the calculation. Minus theta to plus theta, cos of theta d theta. So lambda by 4 pi epsilon naught 1 by r sine of theta minus theta to plus theta. So lambda 4 pi epsilon naught 1 by r sine of theta minus sine of minus theta. So sine of minus theta means what? Sine of minus theta plus theta. So this is equal to 1 by 4 pi epsilon naught lambda by r twice sine of theta. What do you think? Now, if we consider this is the final expression. If we consider this is infinitely long, then the angle theta become 90 degree. Okay, that is the way we actually done in a Gauss's theorem. Okay, thank you.